In this video, we're going to focus on applications of 2x2 linear systems. Applications is just a nice way to say word problems. So we're going to explore lots of different word problems for these sections. Just to kind of give you an general strategy about any word problems in general, the first thing you should always think about is reading the problem and understanding what the problem is asking you to find. If you have any variables to identify those variables, write expressions for any missing quantities containing the variables, and then translate into a system of two equations and two variables if that's the strategy that you're using. Then we're going to solve the system using substitution or elimination. So we'll see the algebraic methods are going to be the most useful. Graphing generally is not useful for application problems because the coefficients might be a little funky or big, or we could have fractions or decimals. We're going to check our solutions to make sure that they work for the system, and then check our solutions for reasonableness. Does it make sense for the problem? And then, of course, make sure we answer the question. The question might not always be what the variable is. You might have to go a step further. All right, so we're going to see a couple of different types of applications. The first type is what we call a number and direct translation application. So we're going to start with question 1 here. This question says the sum of two numbers is 10. One number is 4 less than the other. Find the numbers. So we have two numbers. So our variables would represent each of those quantities. So I'm going to begin by letting x and y be the first and second number. So let x equal the first number, and we'll let y equal the second number. And actually, I'm just going to write the word number too. Remember that variables represent quantities. So from there, I'm going to write any equations. So I'm going to go back to the text. The sum of two numbers is 10. So if the sum is 10, that means that x plus y is equal to 10, which is what you see here. The second relationship, one number is 4 less than the other. So I can try to translate that directly. One number is, so pick one of the variables. We'll say x is equals 4 less than the other. So less than, in this case, means subtraction. I want to be careful about the order of the subtraction. So I could write that as one number, so pick either of the numbers, is 4 less than the other, so y minus 4. So this describes that same sentiment. So I have my system, two equations, two variables. I'm going to decide how I want to solve this system. Since my second equation is already x equals, I'm going to decide to use substitution. So that means I'm going to take, let me label my equations 1 and 2. I'm going to take this expression for x and substitute it into the first equation. So instead of x, I have y minus 4, replacing that, and then plus y equals 10. So I'll solve this equation. Y and y is 2y minus 4 equals 10, and then continue to solve for y. 2y equals 14, which means that y is equal to 7. So I have my y value. My y is 7. And I can find my x value by using one of my equations. So I'll use a second equation. X is equal to y minus 4. But now I know that y is 7. So if 7 minus 4, x is equal to 3. Then I'll just check that I've answered the question. And so the question said find the numbers. I did find the numbers. The first number is 3. The second number is 7. So I've answered the question. Go on to number 2. All right, so for number 2 here, Kenneth currently sells suits for company A at a salary of $22,000 plus a $10 commission for each suit sold. Company B offers him a position with a salary of $28,000 plus a $4 commission for each suit sold. How many suits would Kenneth need to sell for the options to be equal? Okay, so we're going to define some variables here. We're looking for really two variables. So one variable would be the number of suits that were sold, and the other variable would be how much he makes. So let me write that out first in words. So let's let our first variable, and I'm just using X and Y, you could use whatever letters you want, represent the number of suits sold. And let's let Y be his, well, we don't want to say salary because that was used in a different context. So it's his salary, well, it's really his salary plus commission. Okay, it's the amount of money that he's making, but not just the salary on its own, the salary and the commission altogether. Okay, so now we're thinking about two different companies. So in Company A, he's making $22,000 plus a $10 commission for each suit sold. So at Company A, we have the following. So I'm going to label my equations A and B instead of 1 and 2. Company A, it's $22,000 plus $10 per suit. So what he's making is equal to $22,000 plus $10 per suit. If the amount of money he makes for that company can be found by making this calculation. For Company B, the amount of money he makes is equal to, it was $28,000 plus, it was a different amount per suit, let's see. So $28,000 plus $4 of commission per suit. So $4 for each suit sold. And the question says, how many suits should he sell for the options to be equal? So we want what he makes at Company A to be equal to what he makes at Company B. We can also think about this in terms of substitution. I want both of these things to equal the same value, so the same Y, so I could set them both equal to each other. So let me go ahead and do that here. So 22,000 plus 10x equals 28,000 plus 4x. Now you might be thinking, did we really need two variables? And in this case, we could have gotten away with writing this without two variables, x and y, and gone straight to this equation here. But as an exercise, we're going to be practicing writing two equations with two variables. All right, so now that we have one equation and one variable, we can go ahead and solve that equation. So I will subtract 4x from both sides. 22,000 plus 6x equals 28,000. And then I will subtract 22,000 from both sides, and just to give me a little space, I'll do that mentally. So when I subtract 22,000 from each side, I have 6x equals 6,000. 8 minus 2 is 6. And then I'm dividing by 6 on both sides there. So I'll have x is equal to 1,000. So I have the number of suits, which is 1,000. If I wanted to know how much he was making, I would take this 1,000, plug it back into either of the equations. It shouldn't matter which one, because remember the question is saying how many suits should he sell so that he makes an equal amount at both companies. So we could maybe use Company A. So I would do 22,000 plus 10 times 1,000. Which is 22,000 plus 10,000, which is 32,000. So even though the question didn't really ask that, maybe it would. So if he sells 1,000 suits, this answers the question, he would make $32,000 for that year.